So, hello everybody, my name is Fabian Schillinger. The first part of the lecture today was about the text retrieval conference question answering track. So I'm going to talk a little bit about PowerAnswer 4, which was a question answering system developed by Limber Corporation for the text retrieval conference of 2007. The text retrieval conference of 2007 had this question answering track, which we heard already about, where the source data was block data and newswire documents, and they had three kinds of questions. Factoid questions, how many calories are there in a Big Mac? List questions, list the name of chewing gums, and this other questions where the question answering system should give some interesting facts about this target. So PowerAnswer 4 is a distributed strategy-based question answering system. Strategy is based on question processing, and each strategy is designed to solve a specific class of questions. And each of these strategies is a collection of the components question processing, passage retrieval, and answer processing. Here you can see an overview of this of the architecture of PowerAnswer 4 with our three modules: question processing, passage retrieval, and answer processing in the middle. Later we'll talk a little bit about Cogex on the right hand side. And so the question processing module, which is highlighted here, is to determine temporal constraints. Limber used this concept tagger module, which I will explain later a little bit. It's to detect the expected answer type. They used ROSE, a named entity recognition system, to select the keywords used in retrieving relevant passages, and to decide which question class to use. They did process the question semantics in this module and resolved question ambiguity too. So the passage retrieval module ranks the passages that are retrieved by the information retrieval system, and the answer processing module extracts and scores the candidate answers based on syntactic and semantic features such as keyword density, semantic ordering, entity types, and answer likelihood score, which I will explain later. You see, these modules all are partly connected to the internet. And all of these modules have access to syntactic and semantic parsers, named entity recognizer, and some natural language processing libraries. So in the track of 2007, they had block data as a source. They had 175 gigabytes of block data with surrounding HTML and XML. And they had to pass these files to identify unique content, and then they run their tools for language detection to remove non-English text, spam, and empty entries. And in the end, they had 13.1 gigabytes of data, which means a reduction of 92.5%. You see, to handle this huge amount of data, they take some time and yes. So the concept tagger module, which I said earlier, is to process temporal events. It detects events in questions or candidate passages and labels them For example, the event class occurrence, marry, the question who's he planning to marry, or state held, in what city were something held, or a spectral, the begin, on what date did the court begin. And it identifies temporal expressions with absolute dates, times and durations. Absolute dates, for example, 2004, what company acquired IMG in 2004. Duration, 3 months, in 3 months following, or sets each year, how many grants each year. It uses a set of rules working on the full parse tree of the text. And finally, all temporal expressions are normalized. So, for example, the question 249.5 was how many grants does the Fulbright program award each year? And the corresponding passage was the program named after the former Senator J. William Fulbright awards approximately 4,500 new grants annually. So you see each year and annually are normalized to the same. So the next part is ROSE. ROSE is a named entity recognition system which uses a 3-step process. First step is to pass the text through pattern-based grammar system. For pattern matching and lexicon-based information, they had a pattern matching and lexicon-based information extraction engine. The second step was to pass this grammar annotated data through machine learning system to classify recognized named entities such as person, organization, location. And the last step was to perform a partial matching on the text and to index all named entities in the document. So for the answer processing, it's an important question. And finally, COGIX does the final decisions, which answer is the best. But the parsing has a high time complexity, and so Limba had an upper limit of 20 candidate answer passages. So they had to push the most correct answers into this top 20, so COGIX could choose the final answer. The goal was to group the questions from previous tracks into classes and build language model for each class and features extracted from question and answers. They had 3 methods which they tried. The first was to generate regular expression style paraphrases and group them together by paraphrase identifiers. The second method was to use hierarchical clustering based on expected answer types, most relevant keywords, and named entity types. And the last method was group by answer type. For each of these methods, they use the same approach. For questions in classes and correctly judged answers, the following features were extracted. Stemmed keywords, morphological alternations for these keywords, and named entity tags. So this was implemented in 2 stages during question processing and answer processing. And they used the score of this answer likelihood to re-rank these candidates, as I already said, and they had the best observations with the third method, grouping the questions by answer types. They had problems with this regex style. The classes were too sparse and they had a large number of classes with only few instances. In the second method, the classes were it was too noisy and they contained groups of questions that were not necessarily similar. And the last method was the easiest approach. At least they had expected focus which was the same in these classes. So the classes were more robust. One part was the list questions. Here was the strategy to maximize the recall by returning as many answers as possible during passage retrieval. And they used lexical semantic alternations and relaxing the query to include target keywords and most relevant keywords from primary question text. And they had the question how to filter these answers. So they used lists from Wikipedia, for example, discography of some artist or something like that, and integrated Kogex. And of course, they used external data for specialized answer types. They had bots for Amazon and IMDb when the question was in the domain of books, songs, or movies. And of course, a bot for Wikipedia. And they used this Google I'm Feeling Lucky to locate this relevant articles. Something about Kogex. Kogex is a logic prover, and any candidate that scores over some threshold is a potential candidate based on this passage retrieval, and each of these candidates is hypothesized to be the answer. Then Kogex checks if this assertion is entailed by a corresponding candidate answer passage, and only if the entailment score is over some threshold, it returns this as a valid answer. So there were other questions where I could say, give me other interesting facts about something, and the challenge here is to select interesting and novel nuggets from large corpus, and as the passage recall is overwhelming in big data, pruning to pick the best nuggets is very time consuming and difficult, so they used an approach where with definition pattern matching module, they built a list of over 200 positive and negative pre-computed patterns and extended them by hierarchy of nugget patterns and automatically derived generic answer patterns. These patterns are high precision patterns and indicate informations of definitional nature. So the nugget hierarchy based on the question classes from previous tracks, track question sets build 35 target classes, for example animal, actor, musician, literature, and each of this class is associated with a set of minimal information. For example, the person pattern contains full name, birth, death, place of birth, residence, occupation, or the event pattern begin time, end time, duration, location, participants, and something like that. And here you can see some example patterns, nationality, profession, var, and the part of text German Chancellor Angela Merkel, or var opening bracket nationality profession Angela Merkel, Germany's Chancellor, or nationality this JJ profession var Germany's first female Chancellor Angela Merkel. So here are some results of this Limba system. They had in 2007, you see Limba comparison had the highest accuracy in this factoid answer selection with a score with an accuracy of 0.706 compared to 0.494 and 0.289 to the second and third best system. in the year 2006, LIMBA had an accuracy of 0.578, which means an increase of 20% accuracy. For the list questions, LIMBA performed very good too, with an F-score of 0.479 to the second 0.324. In the year 2006, LIMBA had a score of 0.433, which means an increase of 10%. So for these other questions, LIMBA was not the best system, but with a score of 0.281 compared to 0.329 from the Fudan University system, it's about 15% less. So I'm already at the end of my presentation. So thank you.
Question. Yeah. Do you know in the years after, did the other systems improve, or the difference was very big?
They gave up.
They gave up.
They gave up.
Okay.
Yes, I only looked at 2007 and don't have any.
But there was no
results.
question
It was close.
Because they won.
So why the big difference
Which big difference?
in your last table? Why were they so much better? I mean, the others are also not that stupid, I guess. No, in the one with the 0.7.
I don't know. The system was the best, and I only looked at it. And
Yeah, but didn't they say something about it? I mean, usually I think for these kind of tasks you have like an improvement of 1% or 2% is already a great achievement. And it's like, it's huge.
yes, it's huge.
Did they make a statement anywhere in their publications why they think they are so much better?
No, and if you compare to 2006, it's already an increase of 20%, and I don't really know. Yeah.
Were there any time constraints to answer the questions? Or were there just 1,000 questions where did get the best answers to that?
It wasn't really mentioned in my article, so I don't know.
Okay. And this 70%, does it mean that 70% of all questions were answered correctly?
Yes. It's this from this previous from Jennifer. She already said this correct and incorrect and partly correct parts, and this is an accuracy which is I think two real people had to judge the answers of this systems, and so this accuracy came.
The accuracy, and in the next slide,
Yes.
you said about the F-score.
Yes.
It's the same, or?
No, this F-score is score which computes precision and recall, and it was mentioned in some other lectures already. And I had a 9-paper article, and the last chapter was had this 3 values 0.706, 0.479 and 0.281, and this was the results of this article. So I had to find them somewhere else.
Any more questions? Okay, thank you again.